your hats. All right, welcome everybody. Today we're going to go over two things. The first one being AutoCAD. Can you guys still see my screen with AutoCAD shown here?
Yeah.
Yeah, okay, awesome. So I finally started grading stuff like I said I would. Sorry it's been such a delay. So there were a couple of pretty common issues that I noticed between all drawing sets. These are super minor, but I just want to go over them and then talk about how to export PDFs in AutoCAD, because that's something that I didn't go over that I should have. And then from there, we're going to move into Quick PLC. So while I'm talking, go ahead and pull up AutoCAD. And then after we're done there, we're going to move over to the Quick PLC software and program. The first thing that Bill talked about, which is that latching setup that I assigned as homework. And then we're going to talk about counters and then go into some math and assigning. And that should do it for today. And then we'll build off of that on Wednesday. So first things first in AutoCAD. I'll bring over this screenshot. This is an example of something somebody did. So one really common issue is these fuses. A lot of people left these fuses as just F1 when they copied it. So this should be F2, F3, F4, and F5 because they're unique fuses. That's these fuses right here. Also on these spares where nothing's connected, you shouldn't assign an amperage rating to that because it's an empty block. There's no fuse installed in there. And so that should just be a dash or not be there at all. And then here, instead of assigning wire colors and words, you should just say spare. I didn't really talk about that explicitly. I just wanted to point that out. One other really common issue I saw was that a lot of like reference lines, like these lines here that I just circled, were left in. And then a lot of artifacts or remnants from old reference drawings that were copied were also left in. So if you see like here, there's just this little whisker sticking off the terminal block. That's not a huge deal, but it'll drive whoever's reviewing your drawings, it'll drive them nuts if they catch it. So try to avoid carrying over content like that. Overall, everybody did a great job with this. I think the only serious issue I encountered was that some people were struggling, it looked like, with exporting the PDF correctly. And so that's why we're going to go over that right now. So I'm going to open up this copy of all drawings here. So we're going to do two things. First, we're going to go over how to just PDF export a single page. And then we're going to talk about how to do a batch plot, which lets you export multiple drawings at once with a single command. So when you go to print a drawing, so right now I'm in the model space. So if I go to the top left drop down and select print and just hover my mouse over print, you'll see to the right here, there's all kinds of options here. The two that we're going to want is plot and batch plot. So the first one we're going to cover is plot. Now, when you hit plot, it's going to plot whatever tab you're on. So right now I'm on the model space. So if I hit plot here, and then wait for it to hang itself, the default options assigned to this, hopefully they're the same on yours, but there will be a printer. You want this definitely set to some PDF generator. So I have Primo PDF installed. That's a pretty great free software if you want to get that. Otherwise, AutoCAD has different PDF generators here. So like usually you just want to use general document. Okay. So that looks pretty all right. You can change this plot style. I usually use monochrome, and what that does is it just makes it black and white. So I usually recommend plotting stuff in monochrome unless you need colors. because it looks kind of funky and hard to read when you export color drawings. Okay, so I'm gonna hit OK, and it's gonna tell me where it wants to save it and name it something. So I'm just gonna call this test, save it to the desktop. Okay, so that worked. And because I didn't have my settings correct, it basically printed a blank sheet. So you can get the model space to print, but you have to really get the settings right, and it's usually a total pain. So I'm just doing this as a demonstration of why you don't do that. So what we want to do is actually print from the layout tabs. Now this has a huge advantage because we can set, if you remember, I think we talked about this on day 1 or 2, you can set this window in the layout space to be whatever you want. So right now I have it zoomed in on the content I like, right? And so I can now just go hit print, plot, and then I'm gonna select, I'm gonna select Primo PDF. I'm gonna leave it in monochrome. I'm gonna leave it in ledger. So there's all different paper sizes you can have here. And letter is your normal 8.5 by 11. Ledger is 11 by 17. Most schematic drawings you do, you're gonna want to scale them to 11 by 17 in the content, so that they can be printed that way. Because when you start printing out large electrical drawings on 8.5 by 11, it's really hard to read. So the standard is usually to print an 11 by 17 or larger, depending on your application. Okay, so usually like your field stuff, your drawings that you're going to take out of the field and check against an installation and redline, those will be 11 by 17. And then when you print drawings of record that like go into a paper archive somewhere, they'll be the huge like 32 by I forget what the dimensions are, but they're really big, right? But it's impractical to print them that big and go take them out into the field. Okay, so now I got all this set up. I'm gonna hit OK. It's gonna think about it for a minute. It's gonna hopefully have finished. Okay, there we go. So when you use Primo PDF, this is what it does. It basically exports it from AutoCAD into Primo, and then from there you can prompt it to save however you want. And that should be opening, but maybe not. So I saved that as test 2. Let's open that up and check it out. Okay. So that looks pretty good, except this isn't monochrome, which is really weird. So I need to check my settings and see why this didn't print out as black and white, because it should have. But you can see it's scaled correctly. It's pretty much what I want. So let me check that setting real quick, because maybe it changed when I selected something. Oh. You know what I'm going to do is just use AutoCAD for now. So let's make sure this works, because we're going to leverage these settings in a minute when we do batch plotting. That's still not working in monochrome. That's super weird and really annoying. So you can see some of this stuff. Oh, you know what? I bet it's because of the content. Give me 1 second. Okay, I think a lot of the problems we're having are due to the way this drawing is set up. Oh, it's because they're white. That would explain a lot. So part of the problem is the way the layers are set here. There's a lot of problems. So I think this is good enough for an example, but generally speaking, you want to make sure in print and monochrome. Okay, so the next thing we're going to do is, as you see in the model space, there's all this drawing content, right? And we were just zoomed in on this one. So let's say we're not completely finished with the set, but we need to print, we need to physically print a set for drawing verification or something. But we don't want to separate all this content out into individual DWG files because that's super time consuming and we might need to go make edits. And so it's nice to keep it all in this one file. Well, what we can do is create another layout tab. So if you just go on the bottom left and hit that plus button, it'll hang itself for a minute. Okay, so now it created a new drawing. And so what we can do is this outside border that's blue, select that, and we can actually drag it to make it bigger. So drag it up to the edge of those dotted lines, like so. Okay, and then type P space to make sure you're back in paper space. And then double click inside that border and zoom in on whatever you want to be the content for this particular drawing. So in this case, I'm going to pick this power distribution right here, and I'm going to type Z, and then I'm going to type W for window. So Z is zoom, W is window, and I'm going to use my cursor to select the window that I want to be shown in this layout tab. Okay, so that's selected now. That's the spacing I want. I'm going to type P space to get back out of that window. Okay, so now I have this saved. I have it where I want it. So I'm going to go plot. Okay, so this is where we need to start saving our settings. And if you go in the page setup here, there's a drop-down menu, and it'll show any previously saved settings you have, and that, as well as the add option. So I'm gonna, what you want to do before you hit add is set all your settings the way you want them. In this case, I'm going to do the AutoCAD to PDF. I'm going to leave it as 8.5 by 11. I'm going to change this plot style to monochrome. And then everything else looks pretty good. I'm going to leave it like that. I'm going to hit add. And I'm going to call this setup test plot set up. And I'm going to show you why we're doing that in a minute here. But for now, just save test plot setup, hit OK. And then we're going to call this one test number 4. Okay, cool. That looks pretty good. So it actually printed it in monochrome. Now, if you'll notice, these lines are really like thick and blurry. That's because the layer settings for this drawing set are set too thick. So one of the things you should do is go back in your drawing and look at this content, select this here, and go into actually layer properties. And make this bigger so you can actually see it. Okay. And so there's the line weight here. It looks like most of these are set to default. So I'm going to change these to 0.13. Actually, I need to see what content this is where first. Okay, so EL text is the layer that I want to change the line weight on. So EL text right here, default. I set that to 0.13 millimeter. Okay. And then I'm going to save that again. Okay, and I'm going to do that same plot option one more time just to see if that line weight change actually worked. Now, the reason we saved that test plot setup is now I can go into page setup and just select that, and it'll automatically assign all my previous settings without me having to go through and set each one of these. So when you know you have a standard print that you want to do, make sure and add that in your page setup, because that way you can just copy it and not have to manually set all your settings each time. Okay, so now you can see I changed the line weight on the layer that has all the text in it. And you can see on this export, the text is much clearer because it's much thinner. So I set it to 0.13 millimeter. I'm guessing the default is like 0.5 millimeter or something. That's just a guess. But it's too thick. And that's why it looks like these lines are super fat. So generally speaking, you want your line weight to be light enough to where you can still kind of read it even when you're zoomed way out. Now, for certain items in your drawing, stylistically, you might want them to be really heavily weighted on the lines, and you can assign that to a special layer and only use it for that content. But generally speaking, you want to make sure your line weight is thin enough like this. So make sure and set that and play with it when you're exporting. If it's unreadable, it's unacceptable. You can't use those drawings in the field if the line weight is set so thickly that you can't read it. So keep an eye out for that when you're exporting drawings. Okay, last thing, I know this is kind of dry, but it's really important because you need to be able to use these drawings. And you don't want to spend your entire day just printing files out to PDF. You have better things to do. So the last thing I want to show you is batch plot. So we now have, so if you go over to print and then batch plot, we now have our specially assigned print settings. So when you go to batch plot, what it's going to do is it'll pull up this publish pane, and by default, it'll pull up all the tabs you have open in this drawing. So you can see in this drawing, we have 4. We have the model space and then our 3 layout tabs. So go ahead and select the model space and then come up here and hit the remove sheet because we don't want to print the model space. Remove this layout too, because that's something else I was doing. Okay, and then if you go to page setup, you can now select your test plot setup and do both of those. And that test plot setup, if you look down here, actually it doesn't show you all the settings, but you kind of just, I guess, need to know what those settings were in that page setup. Okay, and so now if I go down here and hit publish, this is going to plot all those drawings using the page setup settings that we defined before in test plot setup, which is going to be monochrome, 11 by 17, and print to PDF. So we'll hit that, and then it'll ask us to save it. So test 5. I guess I already have that, test 6. Okay, and then it'll ask you if you want to save the current list of sheets. Now, if you have a drawing set that's pretty well locked in, and you know, like you're doing this for a field, you're printing this set for a field walk, and you know you're going to come back, make changes to the set, and then in the future, at some point, you'll probably have to reprint the set. You can save this list of sheets because that way you don't have to manually add sheets to this list. You can just pull up the list and it'll print the whole list. It's not a big deal when you have like 3, but it is when you have like 100. So I'm going to just go ahead and say no, because I don't need that, but it is a good option to have. So now the one thing about batch plotting is that it does take a little bit longer. And so it'll tell you your printing or publishing job is processing in the background. And it'll prompt you when it's done. But even batch plotting even if it's just 2 sheets, will actually take longer than individually printing each sheet. So while we're waiting for that, does anybody have any questions about what we're talking about so far?
So when I was doing mine, the dashed lines.
You got cut off. What did you say?
Like the dashed lines that we had, it looked like it got cut off. Like the dashes were
really
it's
big.
a lot different. Yeah.
Yeah. So this is something I've struggled with in my own personal life. I'm not exactly sure how that control works. Let me go back to this tab. So what I've found is that what you can do is actually go into the layout space, and the more you zoom in here, when you set this line weight, the more dashed it will be. So if I'm zoomed in really tight, the dashes are really frequent, right? And I can zoom out and they're set. Now, if I zoom out way out here and set that again, they're a lot bigger, right? I'm sure there's a much better way to do this. I just don't know what it is. So I can try to research this and get a better answer. But honestly, like when I was doing my PFD that I showed you last week, this is how I set the dash weight. It's kind of a pain, and that because you gotta rezoom your drawing every time, but it does work. So
Okay. Thank you.
yeah, sure thing. So resume that. Okay, cool. So our plot is finished. I'm gonna go and open up test 6, and we're gonna check out what happened. Okay. So the first thing I notice is that this first drawing got cut off, right? But my second drawing looks pretty good. So I'm pretty happy with that. Again, you'd need to adjust these line weights because it looks funky, but you get the idea. So can anybody tell me what happened with this first drawing?
Is it scaled to 11 by 17?
Exactly. So if you look on layout 1, you can see by eye that it's wider than what's showing. The aspect ratio is wider than what's shown on layout 3. And so Mason's exactly right. This is scaled for 11 by 17. So what you would need to do is go create an 11 by 17 layout, save that as plot settings, and then when you go to batch plot, go to batch plot, get rid of these 2 guys. Okay, so now on layout 1, you use your handy dandy preset 11 by 17 for that drawing. Now let's see if this plots correctly. Okay, so that's the last thing we're going to cover on plotting, unless anybody has any questions. While this is plotting, I would recommend you go ahead and pull up the Click PLC programming. This is a bunch of garbage that I was playing with earlier. Is this still working? Yeah, it's still working. Okay, does everybody have the Click software pulled up?
Yeah.
Sweet. So go ahead and pull up an empty project. I recommend you do what I just did. Pull up your old code that has the PLC layout already in it, and then just delete all the content. Okay, cool. This finally finished. So, okay, going back to our drawings real quick. So I used an 11 by 17 and it pretty much grabbed all the content correctly. Now, this is a little bit cropped because of the way that it's zoomed in the window. So you just need to fix that, but this is pretty much correct. It's pretty much what we want. And then this one looks good. Okay, so now you know how we've re-reviewed how to zoom and scale drawings in that layout space window. And we've talked about how to make new tabs. I guess two things I haven't talked about. You can copy this tab. So instead of manually setting it to 11 by 17, you can just do a move or copy, right? And just recreate this window that you've already scaled the way you want it. And that way you can just rezoom that window to get the content you want for multiples. And then the last thing is when you're doing a batch plot, if you know, let's say you have a bunch of files that you want to plot, but you don't have them all open, you can just drag and drop into the batch plot window from anywhere you want. So for example, I have this simplified PFD drawing. I can just drag that in and drop it in there. And by default, it's gonna put all the tabs that are in that drawing file. And so what you can do to sort that out is actually, I guess, just use the 3D DFW, because then it will put all the model space drawings together and all the layout space drawings together. And so you can just select these model spaces and delete them. And then you can manually just go in and set all these page setup. And I think actually if you highlight these, if you highlight a bunch of drawings and then select the drop down, yeah, it'll set them all to that same page setup. So you don't have to go in and individually set them all. You just select everything, go, bam. So this stuff, as far as the batch plot, probably isn't super important for everything we've done so far, but I just want y'all to be aware of this, because as you start going into multiple sheet drawings, this becomes really, really important to save you time for when you're exporting the drawings. Because if you have to do this manually per drawing, and even if you have a 20 drawing set, that could take you over an hour, even if you're quick. So batch plot is super important when you start scaling this stuff. And then I just noticed, like, there were a lot of issues on some of the homework that got turned in, where the zooming of the window on the PDF export, or the content that was selected is probably not what you were trying to do. So I just wanted to make sure this was covered and that y'all are comfortable with that. Okay, moving onward and upward. I knew that you could spend 30 minutes on printing stuff. Okay, so what we're going to cover now is what was assigned for homework for today. So some of y'all already turned that in. Thanks for being proactive. I don't know if I said this in the assignment or not, but the point was to have you take a stab at this, so that when I do it here live today, you'll kind of see what we're trying to do here. So pretty much everybody had the right idea, but there were a couple of key errors, I guess, that were made, and a lot of the ones that I did see today. And so I'm going to highlight that as we go through it. So the point of this is we want to make a program that when you give the PLC an input, it turns on an output and then latches that output so it's maintained on until we interrupt it by giving it a different input stimulus. Okay. So the first thing we're going to do is assign an input, a normally open contact, which is going to be X101. 1 second, I got to change my screen sharing here. Okay, I think that worked. Can you guys see down here at the bottom? There's you can actually see my hand wiggling its fingers.
Yes, sir.
Yeah, just the row of buttons, right?
Yeah, just the row of buttons and stuff.
Yeah.
Cool. So that way you can see the software and the response live. Okay. So we got our X101, which we know is this white button. Okay. And then we're going to come in here and we're going to draw a parallel rung here. And then we're going to put an output, and I'm going to make this output Y001, which we know is this light right here. Okay. And then in parallel here, and this is where there's some confusion. I'm going to put a normally open contact, and then I'm going to assign that to Y001. Okay. So I noticed a lot of people made this like X001 or something else, which if you have a maintained input works. But what we're doing here is we're saying that when this output Y001 lights up, because of a stimulus from X101, this output lighting up is also going to light up the Y001 contact right here, which will, because it's wired in parallel, will maintain this on even if the external stimulus to X101 is gone. So let's go ahead and download this. Oh, I forgot my end bit. You always got to put your end on there or it screams at you. It's super annoying. Okay, so we're going to write this project to the PLC, and it's going to yell at us because we're doing runtime edits. Okay, so this is a really good opportunity to highlight another potential issue with doing runtime edits, which is you can see this light is still on, right? And that was on from earlier from some test programming I was doing. So what I believe is happening is basically when you write a new program into the PLC during runtime, it doesn't wipe out whatever's stored in the memory. And so somewhere in the memory, this memory bit is set to 1 right now. And in reality for us, it should be set to 0 because we're not even, that's Y003. We're not even touching that right now, right? And so that's a problem because it has all these registers that have values in them that could be doing something in the physical world that we don't really want. So there's 2 ways of dealing with this. The first is just from the software, you can put it in stop mode and then back to run mode. Okay, and so you saw when I did that, it wiped out all the memory, or it reset all the memory registers back to their default values, and that light turned off. The other way you can do this is physically go into the panel and flip the switch on the PLC to off and then back on. But if your panel's live like this and you want to be safe, you don't open the panel. So you can do that. You can do that manually from the software, like I just showed you. Okay, cool. So we're ready to test this software, right? That we just wrote. So I think what's going to happen is when I press that white button, the first red button is going to turn on and it's going to stay on. So let's test that. Yep, it stays on. So even when I'm not pressing the button, this has stayed on. And the reason is because this output is closing this contact, which is keeping this whole rung energized. So how do I turn that off? Anybody?
You can't.
Correct, I cannot. So I could flip the PLC between stop and run mode again, like I just showed you. But that's not practical for everyday operation. So we should probably put some method for doing that. So what I'm going to do is I'm going to put a normally closed bit on this rung and assign that to X102, which, as we know, is this red button here. Bam. And then we're going to write for it. We're going to write this program into the PLC. We're going to do a runtime edit again. It's going to get mad at us again. That light's probably going to stay on again. Okay, so that light's still on. But the cool thing is, because we're actually using that output in our program, we can see why that light is still on. And the reason it's still on is because the memory bit's still assigned to 1 from last time. Okay, so now to reset this, we hit our handy dandy X102 and the light goes out, and we can see on our software that this output has gone out. So that's how that works. Now, if you were to do like a lot of people did and make this like X103 or even here, let's make it X101. You'll see why this doesn't work. In a minute, as soon as we download it and run it. Okay, so now when I press this, both the X101 inputs light up, right? And the Y out lights up. And then as soon as I stop pressing it, they die. And so that's why the whole point of this setup is that it allows you to use this output to latch an input on the controller side. So Bill talked about this. This is a result of the way the PLC scan time works. So what's happening here is the code executes by going top to bottom, left to right. So it starts at the top of this rung, it comes down, and it hits a rung. It says, okay, I'm going to execute this rung. Now, actually, let me write this into the PLC so I can talk through this as we're doing it. Okay, so I'm going to come down here. I'm going to start down this rung. Now, if this rung is energized, if this contact is energized, and this normally closed contact is energized, I can come down here, keep going, and I energize this coil. Cool, that's energized, that output is energized. Now in that same execution, this rung is done. I'm gonna move on to the next rung, which is bam, right here, Y001. Oh, that's lit too. Okay, so now I'm gonna go up and over, and that's lit. Okay, cool. Done with the first scan, right? There's nothing else to execute. Now on the next scan, I take my finger off the button. And by the way, there was like a million scans, not a million, but maybe 1,000 scans in the PLC that just happened while I was talking. Okay, so now that input's no longer energized. I'm gonna come scan along this first line, hit this first rung, come over, that's open. Okay, forget it. This is an open contact, energy can't travel across it. I'm gonna keep moving on. Hit this second line. This one's live, it's closed. So I have energy coming across here. I still have energy coming across this normally closed, all the way to the output. Bam, execute. Okay, so then what happens is to get out of this state of self-energization, all we gotta do is break this contact here, this X102. And by breaking that, as it's scanning, this is open, which means that this is no longer energized, which breaks this being latched, this Y101 being latched, and we go back to our starting mode. So any questions about that? Is that clear? Okay, clear as mud. Awesome. I'm super glad. So the next thing we're going to talk about is counters, because we're going to use this on Wednesday to actually set an analog output from the PLC to the motor. So because we only have 10 minutes left, I'm just going to focus on the counter aspect and the writing aspect, and then we'll talk about the hardware side of it on Wednesday. So on this output here, I'm going to add a counter. Actually, you know what? I'm just going to wipe out all this content here and start from scratch. So I'm going to add a counter. So the counter number, this is basically the memory register where the counter value is stored. And so I'm going to make that, if you click on that ... it'll pull this up. The only type of value that you can assign this is a CT, which is a bit, an integer value. So I'm going to assign that to CT1. Sorry. This is the status for the counter, and it's either on or off, a 1 or a 0. That's why it's a bit. And then for the set point, you can actually go into here. Now this is pretty cool. So you can assign 2 different types here, either a DS or a DD. If you remember, we talked about what those are previously. So you can assign this as being some point in memory that's already assigned to something else if you want to. So you could use this to get like cumulative counts from multiple spots. But what we're going to do is we're going to use an unused. So we're just going to pick DS1 because it's the first one. Okay. I'm going to throw that in there so we can start talking about this. Now, one interesting thing about counters is they have a reset, and you have to wire this reset in. And by default, it doesn't come wired to anything. So you have to use your rung editor to go, oof, gosh. Select right there. Okay, I'm gonna go here. Go over a couple. Cool, that looks good. So now we have wires going to that reset. It's going to be happy. Now, granted, we need to put things on these wires for this to work correctly. So what a counter does is it takes an input stimulus, right? So what you can do for that is put a normally open contact. Again, we're going to put X101 because that's just our go-to button. Okay, and then the reset also needs an input stimulus. And I'm going to just make that X102 just so that we're super clear. Okay, and now what happens is once the set point, sorry, let me go back. By assigning the set point to be a certain location in memory, that allows you to externally write into that memory. So at any point, if this DS1 has a value that's connected to like an operator input, you can go in and type a 5 or a 10 or whatever you want that set point to be in there. The other thing you can do is just hard code the set point value. And so for this example, I'm just going to make it a 5 because that makes their life easier. Because right now we don't have a touch screen that's wired up to this that we can play with. Okay, so I'm going to set that to 5. So what happens is once this current value reaches 5, this CT1 output is going to light up. So what we're going to do is on rung 3, put in a normally open contact for CT1, and then we're going to make this output. We're going to make that Y004. Okay, so this all looks pretty good. This will execute. We just need our end command. Okay, I'm going to write this into the PLC. gonna get upset again. Okay, and we're live. So I'm gonna hit the X101 input, and you can see the current value of the counter just went to 1. I hit it again, it went to 2, 3, 4, 5, 6. Okay, so now once that value's been reached, I can keep incrementing that value as much as I want, right? But it doesn't really make any difference to what's happening with the counter, because once it hits 5, it hits complete, it energizes this output, and the super loud and obnoxious buzzer goes off. Okay, now fortunately for us, we built in a reset of the X102. So all I have to do is hit that button, and it resets the counter value back to 0, and this output is no longer live, and that annoying alarm shuts off. So that's how a basic counter operation works. Now, your input stimulus for the X101, that could be any number of things in the real physical world. But the important thing is just that one press of this equals 1 increment on the counter. Okay, so the next thing we want to do is, you notice when we set up our counter, you can set it to count up, count down, or count up and down. So count down basically works the same way you would think, or it probably works the way you would think in that oh God, that's terrible. The drawing in this is kind of annoying. Okay, that should be all right. Save that. So when we run this, assuming I did this correctly, instead of counting up from 0 to 5, it's going to count down. Yeah. So you can see I didn't exactly set this up correctly, but your starting value, you would need to write something in, and then as you increment down, as you give it down inputs, it increments down. Okay. How do I kill this easily? I'm gonna make this -40. I'm gonna write that out.
So if you have it set to down, then the CT1 activates when you're below the set point?
Right.
Ah, okay.
I should have set that lower. Here we go. Here we go. I'm so good at pressing buttons. See? There you go. Okay. So now we're almost out of time, but we're getting to what I actually want to talk about and what we're going to use next time. You can set this to count both up and down, right? And so what we're going to do is, why are these things never easy? Okay, so now I have 3 rungs. I have my up, I have my count up, my count down, and my reset. So I'm going to set this one to X102. Okay. I'm going to set this to 0. And actually, for this application, our set point really doesn't matter. I just want that alarm to go off if we reach 0 for some reason. So what I really want to do is do a math assignment where this value that's in the math. So what the reason we're doing this is we want to write the speed for our variable drive on our motor. We want to write that value somehow. So what I'm going to do is I'm going to assign that value, and I think it's DF5. Let me just sanity check that real quick. I'll just spoof a value in there real quick. So I'm going to go to PLC, setup, system config. Okay, yeah, so I happen to know from previous stuff that we did in previous classes, the motor drive is wired to DF5. So that means that I can do a math assignment here where I'm going to say that DF5 is equal to our current counter value, CTD1, right? And when it lights up like that, you know it's hyperlinked, multiplied by 10, okay? So what does this do? Well, it allows me, so I know that's an analog value. I know we scaled it from 0 to 100, okay? So that motor controller, the variable frequency drive, is basically looking for a value from 0 to 100. Now, when I did this math assignment, I'm basically saying that whatever I set this counter to, it's going to assign that times 10. So I can set this counter from anywhere from 0 to 10, which sets my motor from 0 to 100. So real quick, I'm just going to test this. Sorry, I'm going over a little bit on time. We'll go back over this again briefly on Wednesday, but I really just want to test this out because we're basically there. Okay. So right now my alarm's going off because it doesn't like that. So I'm going to increment that counter by -2, and you can see that on this math assignment, it actually shows live what that value is. That DF5 value, it's -20 right now. So if I go back up, that's the reset. Oh, I totally screwed up. This should be X03. Sorry, bear with me. This is why you can't walk and chew bubble gum, guys. Okay, so now this should work. Cool. Oh, it's super obnoxious. I should have made that value. I'm gonna make that value 11. That's a good number. We got a chat here. Yeah, so it's an alarm. I'm trying to turn it off. Christina's not a fan of the alarm. Okay, I think I've got it now. So that alarm isn't going to go off until we hit 11 count. So to answer Mason's question, yeah, each time you press the button, it should increment the counter by 1. Okay. So let's see. So X103 goes up, X101 goes down. Okay. So if I count up here, that's incrementing my output to the VFD, which is currently in stop. Okay, you know what? We're out of time. So there's a little bit more programming we need to do to that motor controller to actually make this work. And we're over time. So this is a good spot to stop. So hopefully you kind of followed the mumbo jumbo of what I did. We'll talk about this again on Wednesday and how that scaling works and ultimately what we're really trying to do with that. But hopefully you followed at least the part about the counters and assigning things with math. Any questions? Going once, going twice. All right. Thanks everybody for your time. And I'm going to stop the recording. We can talk offline if you have any more questions.